Welcome to the DIY Honda Garage channel. Welcome to this diagnostic presentation for the DTC P0141, indicating a problem with the secondary HO2S, or oxygen sensor heater circuit, in the Honda CRV models from 2011 to 2016. The secondary HO2S is essential as it monitors the exhaust gases leaving the vehicle after the catalytic converter. This component helps ensure that the engine runs efficiently and complies with emission standards. Its heater circuit is vital for bringing the sensor to operating temperature quickly after starting the engine. If the heater does not function, the sensor will provide incorrect readings, which can negatively affect engine performance and emissions. In our troubleshooting, we'll focus on systematic steps to find the root cause of this malfunction. The error described in DTC P0141 pertains specifically to the secondary HO2S, also known as oxygen sensor 2, which is positioned downstream of the catalytic converter. This sensor measures the oxygen levels in the exhaust gases, helping to optimize the air-fuel mixture for the engine. The heater circuit within the secondary HO2S is critical because it ensures that the sensor reaches optimal operating temperature efficiently. When the engine is started, if the heater is faulty, the sensor may read inaccurate data, resulting in poor engine performance and elevating emissions. This specific circuit is monitored by the Powertrain Control Module, or PCM, which interprets the data from the sensor and makes adjustments as necessary. Thus, troubleshooting this error will require closely examining the circuit and the related components to ensure they are functioning correctly. Several possible causes may lead to DTC P0141 being triggered. A primary suspect is a faulty secondary HO2S itself. If the internal heater circuit fails or malfunctions, it will cause the error code to appear. Another possible cause could be a shorted IG1 ACG wire, which connects the sensor to the vehicle's electrical supply. This can disrupt the power flow needed for the heater circuit. Additionally, a bad connection at the PCM can prevent accurate readings and normal operation. Lastly, there may be an issue with the SO2HT line, the wire responsible for transmitting data from the secondary HO2S to the PCM. Each of these components needs careful examination during troubleshooting. The symptoms associated with DTC P0141 may vary, but generally include an illuminated check engine light. When the system detects an issue with the secondary HO2S heater circuit, it triggers this warning. Drivers may also experience poor engine performance, particularly during acceleration or idling, as the engine struggles to achieve the correct air-fuel ratio. Additionally, increased emissions can lead to failing an emissions test, as the data sent by the sensor is critical for monitoring and adjusting fuel efficiency. Drivers might also notice unusual exhaust odors, an indicator that the engine is not functioning optimally. Therefore, timely identification and resolution are vital to maintain vehicle performance and compliance with emission standards. The first troubleshooting step involves turning the ignition switch to the on position, which powers the vehicle's electrical systems without starting the engine. Then, we clear the diagnostic trouble codes, or DTCs, using the Honda Diagnostic System, known as HDS, which resets the system. Next, we start the engine and let it idle for a short period, allowing the vehicle systems to assess any changes in sensor readings. After idling, we will check again for any pending or confirmed DTCs using HDS. If DTC P0141 appears, we confirm that the failure is persistent, indicating that further investigation is necessary. If not, it may signify an intermittent failure, suggesting we should inspect for any poor electrical connections or loose terminals associated with the secondary HO2S and the PCM. In this step, First, the ignition switch is turned to the lock position to safely perform tests without power to the system. The next task is to check fuse number B2, rated at 10 amps, which can be found in the under-fuse relay box. It's crucial to verify that this fuse is operational, since it supplies power to the IG1 ACG wire connected to the secondary HO2S heater circuit. If the fuse is intact, it suggests that there is no short in the wire between the secondary HO2S and the fuse, allowing us to proceed to the next step. Conversely, if the fuse is blown, it indicates that there could be a short in the IG1 ACG wire itself. In this case, repairs should be made in the wire, as well as replacing the blown fuse before continuing with troubleshooting. For the third step, we begin by disconnecting the secondary HO2S, specifically the 4P connector. This action isolates the sensor, allowing for a more accurate resistance measurement. Using a multimeter, we then measure the resistance between test points 1 and 2 on the sensor side. This test should be done under the condition of the ignition switch in the lock position and with the sensor disconnected to prevent any erroneous readings. The resistance value should fall between 5.4 and 7.3 ohms at room temperature. If the measurement falls within this specified range, we can conclude that the secondary heater circuit is functioning as intended and move on to step 4. If the resistance does not fall within this range, it indicates an internal failure within the secondary HO2S, requiring replacement before proceeding further. This fourth step focuses on checking the internal circuit of the secondary HO2S. With the ignition switch still in the lock position and the 4P connector disconnected, we will measure continuity between test points specified. This helps ascertain if the sensor's internal components are functioning correctly. The test conditions require that both the sensor's connector and body ground are connected correctly. If there is continuity, this confirms that the internal circuit is functional, necessitating the replacement of the sensor as indicated by previous steps. If continuity is not detected, we proceed to step 5 to locate any potential failures in wiring or connections related to the SO2HT line or other components. In this step, we power the ignition to the on position again, activating the system, but without starting the engine. We will measure the voltage between specified test points in the 4P connector of the secondary HO2S. This voltage measurement is crucial, as we are checking if battery voltage is present. If we confirm that battery voltage exists at these points, we can infer that the wiring to the sensor is functioning correctly, prompting us to move to step 6. Should battery voltage not be evident, however, we need to troubleshoot further to find an open circuit or faulty connections, particularly concentrating on the IG1 ACG line, which has implications for power to the heater circuit. Here we again turn the ignition switch to the lock position to ensure safety while working on the circuit. We will jump the SES or short circuit suppressor line using the Honda diagnostic system to proceed with testing continuity. The next step involves disconnecting the PCM connector B, which contains 49 pins, thus isolating the computer control for examination. We then check for continuity between test points in the disconnected condition. This step is critical because if continuity is present between the PCM and sensor wiring, it suggests a short, which requires immediate attention and repair prior to moving ahead. If continuity is absent, the wiring may be intact, and we may need to consider updating the PCM software or substituting it with a known good part for further diagnostics. Now, we will measure voltage at specific test points while the ignition is set to on. Again, we are looking for battery voltage. If we find battery voltage present at these test points, we can confirm the integrity of the IG1 ACG wire. If this is the case, we'll move on to step 8 for further evaluation. However, if there is no voltage reading, it indicates a possible issue, likely in the wiring between the number B2 fuse and the secondary HO2S. In such a case, we must perform repairs to rectify any open circuits or shorts and ensure that the signal flow through the designated lines is maintained to allow for the proper operation of the heater circuit. In this final step, we once again commence by setting the ignition to the lock position. Similar to the previous steps, we will jump the SCS line utilizing the Honda Diagnostics system. After that, we disconnect the necessary connectors to examine the circuitry more accurately. We will measure for continuity again, now focusing specifically on the SO2 HT line, which conveys signals from the secondary HO2S to the PCM. If continuity is confirmed, we can deem that wiring is intact and may need to update or substitute the PCM if necessary. If there is no continuity, it indicates that there is likely an open circuit or an issue within the SO2 HT wiring that requires repair before concluding the troubleshooting process. The final repair verification is a crucial step to ensure all previous fixes have been effective. Start by turning the ignition switch to the lock position for safety. Next, reconnect all previously disconnected connectors, making sure they are secure and free from corrosion. With everything in place, reset the Powertrain Control Module, or PCM, using the Honda Diagnostic System to clear any existing DTCs. After this process, we will need to monitor the OBD status to check if DTC P0141 still appears. The HDS will display whether the system has passed, failed, or is not yet completed. If the status indicates that the tests have passed, our troubleshooting process can be considered complete. To prevent future occurrences of DTC P0141, regular preventive maintenance on the vehicle is essential. This includes routinely inspecting the oxygen sensors, specifically the secondary HO2S, as part of the vehicle's maintenance schedule. It's also advisable to check and clean the electrical connections to ensure they are free from corrosion or damage, which can lead to faults. Keeping the PCM software updated is crucial for optimal performance, since outdated software may not properly interpret sensor data. Lastly, constantly monitoring for warning lights can help catch any issues before they escalate. Implementing these maintenance strategies will help ensure the vehicle runs efficiently and sustainably, reducing the likelihood of future sensor-related errors. In conclusion, understanding the significance of the secondary HO2S and the heater circuit is vital for maintaining optimal engine performance and ensuring compliance with emissions standards. The systematic troubleshooting steps outlined provide a comprehensive approach to diagnosing and resolving DTC P0141 issues. Following each step carefully allows technicians to accurately identify faults without unnecessary replacements. Regular maintenance is paramount to preventing future issues, such as monitoring sensor performance and keeping electrical connections in check. Ultimately, the goal is to ensure that the engine runs efficiently while minimizing emissions, helping to protect the environment and contribute to the longevity of the vehicle. Please like and subscribe to the channel. See you next time.